Welcome, fellow chemists, to the first general chemistry video on the channel, where we will investigate the 5 basic types of chemical reactions. Now, you may find a source mention more than 5, and in most cases they are mentioning a variation of one of the main 5. I will point those out when I get to them. But before we start, what exactly do we need for a chemical reaction anyway? The first thing we need is something to react, which is appropriately named a reactant. When the equation used to describe the reaction is written properly, the state of matter is also included. This means S for solid, L for liquid, G for gas, and AQ for aqueous or in solution. A reaction does not require a second reactant, but there is one here. It looks like a math problem now, and in chemistry, the equal sign is an arrow pointing to the right. To the right of this arrow, we find the products, or in this case, product. This equation still isn't written properly because if you haven't noticed, a chlorine has disappeared. We can fix it by balancing the equation with the addition of coefficients. However, that's a topic for another day, and I want these equations to be as clear as possible, so I will not include two things: coefficients or states of matter. Doing this allows us to focus on what the elements are getting up to. Speaking of elements, in this reaction, two elements make one product. But it can be one element and a compound, or even two compounds forming one product. In fact, it can be 3 reactants or even more. In all of these examples, we are combining reactants into a single product. Not only is this where we get the name from, combination, but it also helps us easily identify this type of reaction. Combination reactions have one product and is the only one of the 5 with this property. These reactions, also called synthesis, are often presented in the general form A plus B yields AB. Just remember that A and B can be elements or compounds and you're good to go. If we can combine substances, we can uncombine them too. Here, calcium carbonate is broken down into calcium oxide and carbon dioxide. So-called decomposition reactions involve one reactant forming multiple products. The products do not have to be 2 compounds, of course. Water decomposes into 2 elements, and potassium chlorate into a compounded element. You can even have a single compound producing more than 2 products. If you're thinking this is the opposite of combination, then you are absolutely correct. Which means our general form is opposite to AB yields A plus B. And out of all 5 reaction types, decomposition is the only one with one reactant. We've seen multiple reactants with one product, and one reactant with multiple products. Now for the first encounter with multiple reactants and multiple products. In this reaction between zinc and hydrogen chloride, zinc and hydrogen switch places and we get hydrogen and zinc chloride as products. Zinc was originally a single element, and now hydrogen is. This type of reaction is called a single replacement. Unlike the previous 2 reaction types, where we could change the amount and types of reactants or products, all single replacement reactions look similar. Now, you may be aware that we can predict whether a single replacement reaction will occur by utilizing a list of the elements known as the activity series. This is certainly true, but also a topic for a separate video. We can easily make a general form of this equation: A plus BC yields B plus AC. What you'll need to remember is sometimes it will look like A plus BC yields C plus BA, but it's the same thing. Regardless of what is being replaced, how do we recognize this as easily as the previous 2? Well, it's called single replacement, and there must be a single element as a reactant and a different single element left forever alone as a product in these reactions. Now on to double replacement, where the states of matter are actually useful. Similar to single replacement, 2 elements swap places, but what do we notice about the final equation? The reactants are both solutions, but the products are a solution and a solid. The solid is known as a precipitate because it falls out of the solution. While there will be one product remaining in solution, the other does not have to be a solid. It is possible to form a gas, or even a liquid, most commonly water. There are a few ways to distinguish this reaction from the others. First, we find 2 reactants in solution. Next, 2 products, one is in solution, and the other definitely not. Finally, the reactants and products are all compounds, no single elements involved. The general equation is AB plus XY yields AY plus XB. There are 2 reactants, 2 products, and at least 2 elements in each substance. None of the previous 4 reactions had any requirements on the elements involved, but that all changes with the 5th and final type, combustion. You might already know the element required for combustion, but for those unaware, it's oxygen. This makes it easy to identify because oxygen must be a reactant. The general form looks like this, which ticks all the boxes for combination though. Some sources may define it as not only requiring oxygen, but also specifically producing carbon dioxide and water. To do that, the compound burned definitely contains carbon and hydrogen, and possibly oxygen. Putting additional requirements on the definition, like a specific pair of products, means it no longer overlaps with combination. This certainly ensures the 5 types remain unique, which may make learning them easier. We can summarize everything we have learned with a nice chart. We can recognize combination with their lone product, and decomposition with their one reactant. Single replacement reactions have a single element as a reactant and a different single element as a product. Double replacement reactions have two compounds as reactants and two new compounds as products. And finally, combustion reactions must have oxygen as a reactant. As the video comes to an end, I'm going to put up some problems where you can practice with this chart. But first, thank you very much for watching. If you're new to the channel and want more, click subscribe. If you liked it, click the thumbs up. Finally, if you really want me to cover a topic, leave a comment below.